Let's talk about boundary value analysis, which is also part of specification based test technique. Specification based test technique, we also call it as black box test technique. And this is from, finally, this is from dynamic design technique. Okay, so let's talk about what is it and how we can use it. Okay, boundary value analysis is used to test the input on its boundaries, assuming that most of the defects occur at boundaries. Boundary value analysis testing technique is used to identify errors at boundaries rather than finding those exist in the center of input domain. For example, age field accepts the range 18 to 100. So here we need to identify a set of test cases by applying the boundary value analysis. Okay. So when you say, so 18 and 100, okay, 18 is the minimum value that a system will accept, and 100 is the maximum value that a system accepts. That's the reason I made it as minimum 18 and maximum 100. Okay. Now we have to apply plus 1 and minus 1 for the minimum and maximum. Okay, when I apply min plus 1, it will become 19, and minimum minus 1, it will become 17, and max plus 1, it becomes 101, and max minus 1, okay, 99. Here max is 100, right? Okay, 100 plus 1, it becomes 101, and max minus 1, it becomes 99. Okay, if you see here, the valid data are 18 and 100. Okay, and 19 is also valid, and 99 is also valid. Okay, let's talk about invalid. It is minimum minus 1. Okay, below 18 is called invalid, and after 100. Okay, so 101 here. So you need to understand that, so we talk about just one value ahead or before. Okay, so after 100 everything is invalid, right? After 100 everything is invalid, and below 18 also everything is invalid. Okay, so but we are not taking all the values, we just focusing on the boundaries. Okay, so 18 and 100 are called on boundary values. So let's take an example. 18 and 100 are called on boundary values. Okay, so when I say, so before 18 and after 18 also we can apply. Okay, so but we have to say plus 1 and minus 1. Okay, 17 and 101, okay, are of boundaries, and 19 comma 99. Okay, so if you see here, so let me take a paint example, you'll be able to understand more clearly. Let's take this one. So 17, 18, 19. Okay, now it's a 100, right? 101, 99. Okay, so let's identify what are the on boundaries. So this is called on boundaries, and these are called in boundaries. And this says this is called of boundaries. Okay, so we need to test between 18 to 100. Okay, and before 18 all the values, and after the 100 all the values, we don't need to test it. Okay, so what boundary value analysis says that let's apply a boundary value technique and identify the set of test cases. Okay, let's say 18 and 100 are the given range for us. Okay, so just apply +1 and -1. Okay, that is 17 and 19. Just apply +1 and -1 for the maximum number, that is 100. Okay, 99 and 101. Okay, take these values, take these 6 values and apply. And there is also one more thing we have to say. There is also take the mid. Okay, so this is called mid value. This is called mid value. You also have to test with one of the mid value. Okay, total how many test cases you got? 1, 2, 3, 4, 5, 6, 7. That's it. Okay, so just with 7 test cases you can able to test all this input data. Otherwise you have to take 18 to 100, between all the numbers, with all the numbers you have to test it, and before 18 and after the 100 you have to test it. Okay, so you don't need to do all those things. If you can apply boundary value analysis to a input range, you will be able to get the minimum set of test cases, yet it cover maximum functionality. Okay, and most of the defects are occurs at boundary rather than occurring it in the middle of the data, that is between 18 to 100. In the middle of the data, most of the defects are accurate boundary value analysis, sorry, at the boundaries. That's the reason this boundary value analysis technique got arrived. Okay. So if you see the definition, boundary value analysis is to test the input on its boundaries, assuming that most of the defects occur at boundaries. Okay, so most of the defects are occur at boundaries. That's the reason this technique is came into picture. Okay, so if they give, if there is a field and there is a input range, okay, make sure you can able to apply boundary value analysis. If there is a range, the minimum and maximum range, okay, then you can definitely able to apply the boundary value analysis, and you can able to get the, you know, a good number of test cases, using which you can able to identify the, you can able to test the maximum functionality. So that's about boundary value analysis.